We're going to start off topic number 7 with a review of functions. I would pause the video and write down these notes. So a function is a relationship or equation that assigns every value x in a set we call the domain to a single value y or its image in another set we call the range. So for every x value, there's exactly one y value. The notation that we use is y equals f of x. This can be really any letter, usually something that relates to whatever problem you're looking at, and this is f of x, not f times x. This is your y coordinate, this is your x coordinate variable that you're using. And it means the value of f at the number x. Vertical line test, so we use the vertical line test if we're given a graph of an equation to decide whether or not it's a function or not. If it passes the vertical line test, which means if you draw a vertical line at any place in the graph, it can only pass the graph at one point. So this first one would be a function, versus over here, if I draw a line through this one, a vertical line, it crosses the graph in 2 points. So there's one x value that has 2 different y values, so that would not be a function. So whenever you have something inside your function notation, so f of -3, that means you're going to replace every x in the original function with a -3. So go ahead and pause the video and evaluate f of -3. So for f of -3, I replace every x in the original function with a -3. So you have 2 times -3 quantity squared minus 3 times -3. Well, -3 quantity squared is 9. -3 times -3 is +9. So you have 2 times 9 plus 9, which is 27. If you have something on the outside of your f of x notation, that means it's being applied to the entire function. So you want to multiply the entire function by a -1. So go ahead and pause the video and simplify that. So for this one, you're going to multiply the entire function by a -1. So I have a negative times the quantity 2x squared minus 3x. Distribute the negative all the way through, you end up with -2x squared plus 3x. On this one here, you have f of x, so you're going to take the whole function f of x, and from that, you're going to subtract the quantity f of 3. And for this one, x plus 3, all of that is inside the function notation, so you're going to replace every x in the original function with the whole thing x plus 3. So try those two and simplify as much as possible. So for the first one, you get f of x, which is just 2x squared minus 3x, minus f of 3. So for every x in the original function, I replaced it with a 3. So you get 2 times 3 squared minus 3 times 3. All of this here simplifies down to 9, so you end up with 2x squared minus 3x minus 9. For f of x plus 3, I'm going to take every x in the original function and replace it with an x plus 3. So I have 2 times x plus 3 quantity squared minus 3 times x plus 3. Foiled this all out, you end up with x squared plus 6x plus 9, and then I distributed the -3, you get -3x minus 9. Distribute the 2 through, simplify, and you end up with 2x squared plus 9x plus 9. Some properties of functions. The first one is a secant line. If you take any graph and choose 2 points on that graph and connect the line between those 2 points, that's called the secant line of the graph between those 2 given points. And you can find the slope of this secant line. So if this point here is x1 comma f of x1 and this point is x2 comma f of x2, then you'd find your gradient or your slope using your rate of change, your slope formula. So f of x2 minus f of x1 over x2 minus x1. And this is also called the average rate of change between these 2 given points. So average rate of change and slope or gradient are the same thing. Some more properties or ways that we describe graphs of functions are using these key terms. So go ahead and pause the video and write down these notes. So the first one is increasing. We say a graph is increasing, which as its x's are increasing, or as we go to the right, the function is also increasing. So as your x's are getting bigger, your y's are also getting bigger, so something that's going up as you read left to right. Decreasing, as your x's are increasing, your function is decreasing. So as you're reading from left to right, as your x's are getting bigger, your y's are getting smaller. Constant, as your x's increase, the function neither increases nor decreases, so it's a horizontal line. So as your x's are getting bigger, or as you're reading from left to right, it's just staying constant. It's neither going up nor down. A local maximum is anywhere that your function goes from increasing to decreasing. It's the highest value in a certain interval. So anytime it goes up and then down, that point is your local maximum. There could be 0 local maxima, or there could be an infinite number of local maxima. A local minimum is the lowest point, or anywhere that your graph goes from decreasing to increasing. So the lowest point in a certain interval, again, there could be 0 local minima, or there could be an infinite number of local minima. So you can use your graphing calculator to estimate local max and local min of a function and use that to help you find the intervals for which the function is increasing and decreasing. So here's a video of me using a graphing calculator to find a local maxima. To use your graphing calculator to find minima and maxima, local min and local max, first you're going to go into y equals, and under y1 you're going to type in the function. So we have here 6x cubed minus 12x plus 5. And then you're going to hit graph. So here we have the function, it's nice and graphed. You can see we're missing our local max up here. So I need to adjust the window. So I'm going to go into the window and I'm going to change the y max to 15. And now hit graph again. Because I need to be able to see both the min and the max. So you can only do one of them at a time. It doesn't matter which one you choose to do first. I just pick one. I usually go left to right. So I'm going to find the local max first. So we're going to hit second trace, which is calc, and we're going to, whichever one you're choosing to do, you're going to pick that one. Since I said max, we're going to go down here to max first. So then you need to use your left and right arrow keys, and you're going to move until you are to the left. It says left bound here, so you're going to move until your flashing cursor is to the left, just slightly to the left of your maximum value, and then you're going to hit enter. And then you're going to move until you are slightly to the right of that same maximum value. Okay, just slightly to the right of it because it says right bound, and you're going to hit enter again. Then you're going to move, it says guess, so you're just going to move your cursor until it's basically on that intersection point, or excuse me, that maximum point, and you're going to hit enter one more time, and there are your maximum values. So the actual maximum value is 11.5. Where it occurs is this x value here, negative 0.816, but the max is 11.5. So then you would go through the same process to find the local minima. So go ahead and pause the video and try and find the local minima. So if you do the same thing again, but you go in and use minimum, left bound, right bound, guess, you end up with our local minima here to be at negative 1.53 at the x-coordinate of 0.186. So again, you can use these x-coordinates to help you find the where it's increasing and decreasing. So it's going to be increasing here as I'm going from left to right. My y-coordinates are going up all the way from negative infinity to I get to this local maxima point. So from negative infinity to negative 0.816, we're using x-coordinates now because we're talking about intervals, it was increasing. And then it starts increasing again here at our local minima and increases on until infinity. So it's also increasing, so we use union, it's also increasing from 0.816 to positive infinity. So that's where it's actually going up. And then decreasing, it's only decreasing in this one section here in between our maxima and our minima. So it's decreasing from negative 0.816 to positive 0.816. So that is the interval in which it is decreasing. Here's a graph of possibly a function and a bunch of questions about it. So go ahead and pause the video and answer questions A through J about this possibly a function. Okay, so yes, it is a function. It does pass the vertical line test. This is a hole right here, so even if I draw a vertical line, it would technically only pass through this point here. It would not pass through this point. This point does not exist. So yes, this is a function. F of negative 1 means what is your y-coordinate when x equals negative 1. So when x equals negative 1, our y-coordinate is, I'm going to assume 1. F of 0, when x is 0, y is 0. So f of 0 is 0. When x is 2, f of 2, y is 4. It's the one that is actually filled in. So f of 2 is 4. Is f of negative 4 positive or negative? So I go to negative 4, I find its y-coordinate, and it is negative. So it is negative. Well, for what values of x is f of x greater than 0? So does that means where your y-coordinates are positive. At negative 2, it's crossing the x-axis, so it's technically 0, but anything from negative 2 not included to 0 has positive y-coordinates. 0 does not. A y-coordinate of 0 is not positive nor negative. And then everything from 0 to positive infinity, all of these are positive y-coordinates. What is the domain? So we have a closed circle right here, so it's going to start at, I'm going to assume, negative 6. And then we have an arrow on this side. Everything is taken in between, so it's negative 6 included up to positive infinity. Range, it starts down here, the lowest is -4, and then it goes up. All of this is taken, all of this is taken, and it stops at +4. So from -4 to +4. What are the x-intercepts? Where it crosses the x-axis at -2 or touches the x-axis, and +0, or +0, just 0. What are the y-intercepts? Where it crosses the y-axis at y = 0. What are intervals? Is it increasing, decreasing, or constant? So increasing means as I'm reading from left to right, it's going up. So from -6 to -1, and also from 0 to 2. So from -6 to -1 and from 0 to 2. Where is it decreasing? If I'm reading from left to right, where is it going down? So from -1 to 0, it is decreasing. And where is it constant, which means it's neither going up nor down, it's a horizontal line from +2 on to infinity. Local min and local max. Local min is anywhere that it goes from decreasing to increasing, so down to up, which would be here at y = 0. Local max is anywhere where it goes from increasing to decreasing and is nice smooth curve. This is not a local max because it's a point, so there is no local max. Here are a list of parent functions that are useful to know and little sketches of them just to kind of refresh, since we haven't talked about them much this year. So you have your linear function f of x equals m, which is your slope, x minus x1 plus y1, where x1, y1 are any point on the graph. Your quadratic function f of x equals a times x minus h quantity squared plus k. Looks like that. Your parabola. Cubic, f of x equals a times x minus h quantity cubed plus k. Looks like this. Exponential function f of x equals a times b to the x plus k, where you have a horizontal asymptote at y = k. And rational function f of x equals a divided by x minus h plus k, where you have a horizontal asymptote at y = k and a vertical asymptote at x = h. A little bit of review of linear functions. I would pause the video and write down these notes if you feel like you need them. So standard form and slope-intercept form, those are both on your formula booklet. Standard form, ax plus by plus d is equal to 0, where a, b, and d are not fractions. Slope-intercept form, y equals mx plus c, where m is your slope and c is your y-intercept. Point slope form, y equals m times x minus x1 plus y1, where m is your slope and x1, y1 are any point on the graph. Gradient, which we usually call slope, is your change in your dependent variable divided by your change in your independent variable, change in y over change in x, or y2 minus y1 over x2 minus x1. So using all of these, a little bit of review of linear functions and writing linear equations. Go ahead and pause the video and write down these 3 linear equations. So for the first one, I had to find the slope because they don't give us a slope. They just give you 2 points, 2, 4, and -3, 9. So change in y, 9 minus 4 over change in x, -3 minus 2. Make sure they're in the same order. So you end up with 5 over -5, which is a -1. It doesn't specify what formula line to write it in, so you can write it in any form. If you left it in point slope form, it would be either y equals -1 x minus 2 plus 4, or y equals -1 x plus 3 plus 9. The -9 and the -4 could also be on the other side. If you simplified it into slope-intercept form, it'd be y equals -x plus 6. If you wrote it in standard form, it'd be x plus y minus 6 equals 0. Make sure you can go between all 3 of these. If you haven't already done so, go ahead and pause the video and do B and C, or 2 and 3. So for the second one, they tell us that it has an x-intercept of 7 and a y-intercept of 3/4, which is the same thing as telling us it has the point 7, 0 and the point 0, 3/4. So I found the slope, y2 minus y1 over x2 minus x1, is -3 over 28. So then point slope form, y equals -3 over 28 x minus 7 plus 0, or y equals -3 over 28 x minus 0 plus 3/4. But they give you the y-intercept, so you might as well write it in slope-intercept form. Y equals -3 over 28x plus 3/4. If you want to write it in standard form, multiply everything by 28, get everything over onto one side, and you end up with 3x plus 28y minus 21 is equal to 0. For the last one, they give you the slope and a point, slope form, slope, point, slope form. Y equals -2/3 x minus 4 minus 8. If you wanted to put it into slope-intercept form, distribute the -2/3 in and simplify. Y equals -2/3 x minus 16 over 3. If you need to put it in standard form, multiply everything by 3. 2x plus 3y plus 16 is equal to 0. So modeling with functions, point of all of this is to use this in the real world. So one example is Nimi and her theater studies group are presenting a show at the Iowa Festival Fringe, and she is in charge of publicity. She needs to order leaflets to advertise their show. A local printer quoted her $40 to set up and 2 cents for every leaflet. We want to write the cost function in the form of C of P is equal to MP plus C, where P is the number of leaflets sold and C of P is the total cost. So given the information, go ahead and pause the video and find the function that represents this situation, and then also the price of 600 leaflets. So in this situation, the 2 cents is your slope because it's the change for every leaflet. So it's every time you can see this that's your slope. So it's 2 cents, it's the price per leaflet, and then the $40 is your y-intercept, because even if you buy 0 leaflets, it's still going to cost you $40. So your initial value. So C of P is equal to 0.02 P plus 40. So if you haven't already done so, go ahead and pause the video and find the cost for 600 leaflets. So plug in 600, C of 600, so 0.02 times 600 plus 40, it ends up being $52. So given the same situation, she quoted another printer which told her that it would cost $32 as an initial cost and then 3 cents for every leaflet. So go ahead and pause the video and write a new function, D of P, for this second printer. The cost she finds to be $77. How many leaflets would she order? And then what is the break-even point? So when would they cost the same between the two printers? So for the first one, same thing, 0.03 would be your slope because that's your change per leaflet, and then your initial value, even if you buy 0 leaflets, would be $32. So D of P is equal to 0.03 P plus 32. If the bill was $77, how many did she order? So set D of P equal to 77 and solve for P. Subtract 32 from both sides, divide by 0.03. It was 1,500 leaflets. And then what's the break-even point? So it starts off with the second one being cheaper, but the price per leaflet is more expensive. So we want to know when do they cross, when is it equal. So set them equal to each other, solve for P, and you end up with 800 leaflets. So before 800 leaflets, the second printer is cheaper. After 800 leaflets, the first printer is cheaper. So another modeling problem is that the height of the ball thrown into the air can be modeled by the quadratic function h of t equals a plus bt minus 4.9 t squared, where t is time in seconds after the ball is thrown, a is initial height in meters, and b is initial velocity. So Amy is playing with a tennis ball. When the ball is at a height of 1.2 meters above the ground, she hits it vertically upwards with an initial velocity of 22 meters per second. What is the ball's height after the 2 seconds? So here we have the initial height, and here we have the initial velocity. So you can use this information to find h of t and then find the height. So go ahead and pause the video and try that. So if I plug this in the calculator, again, A is 1.2 because it's the initial height, and B is 22 because it's the initial velocity. So you end up with 1.2 plus 22t minus 4.9t squared, where t is 2. And so you end up with the height after 2 seconds is 25.6 meters. So same situation, except for Catherine hit the ball harder, and so she hit it vertically upwards with an initial velocity of 26 meters per second and an initial height of 1.5 meters. So when the ball reaches a height of 35.9 meters, we want to know how long it's been in the air. So go ahead and pause the video and solve for time. So I've created the function h of t equals 1.5 plus 26t minus 4.9t squared, and I want that to equal 35.9. And then I'm going to use my graphing calculator to solve for t. So I have here, I went into y equals, and I put in y1 to be 1.5 plus 26x minus 4.9x squared, and y2 to be 35.9. You could have also used the polynomial solver too. I changed my window. So I just went from 0 to 5 in the x's, and I went from 34 to 37 in the y's because we just need to be able to see 35.9. So now I'm going to hit graph, and you can see there's 2 places. It says when it reaches, so I'm going to assume it's talking about the first one. So I'm going to find where these 2 graphs intersect. So I'm going to go to second trace, and I'm going to go to intersect. And I want first curve, so I want to get my cursor, my blinking cursor, right about onto where the intersection is. If it's not there, you're going to use the left and right arrow keys until it's there. You're going to hit enter, and then second curve, usually you don't even need to move your cursor, hit enter again, and guess one more time, and we are looking for the x coordinate. So we are looking for 2.512 seconds. So the time it takes to be, or the time that it was in the air was for 2.51 seconds. This has been a review of functions.